Hey, hello everyone. Welcome back to my maths homework. So let's do the first question. You have to insert six geometric means between 27 and 1 by 81. So you have 27 and then you have six geometric means and then 1 by 81. So from 27 to 1 by 81, there are going to be 1 plus 6 plus 1, which is going to be 8 terms. Yeah, I think so. No, wait. Okay, so till this last gm, there are going to be six jumps, and then there's going to be one more jump, so seven jumps, which means that 1 upon 81 upon 27, this is supposed to be 7 r to the 7th power. Yeah, so r times r times r 7 times. Fine. So from that we can get 1 by this is going to be 3 to the 4, I think, and this is 3 to the 3. Okay, so that's going to be 1 by 3 to the 7, or 1 by 3 whole raised to 7th power, that is r to the 7th, which means that r is equals to 1 by 3. So these gms, these are going to look something like this: 27, then you have 9, then 3, and then 1, and then 1/3, then 1 by 9, and 1 by 27, and finally 1 by 81. So these are those six gms which we had to insert. Fine. So there are 1 2 3 4 5 6 of them. Correct. Let's go to the next question, which is you have to insert five geometric means between 16 and 1 by 4. Fine, which means that 1 by 4 upon 16 is going to be that common ratio raised to the sixth power, because you have to do 5 plus 1 jumps. Fine. So this can be written as 1 by 2 to the, this is 4 plus 2 equals to 6 power, equals to r to the 6, which means that r is equal to, now yeah, r is equals to half. You cannot take negative half because you have to find geometric means between 16 and 1 by 4, so all of them must be positive, because 16 and 1 by 4 are positive. Okay, cool. So the ratio has to be a positive quantity, it cannot be alternating. Fine. Okay, so what do we do with this? Yeah, just generate the whole sequence. Fine. So your first term is 16, then it is 8, then it's 4 2 1 half, and 1 by 4. So these are 1 2 3 4 5 gms, and yes, this is correct because we had to insert 5 gms. So that's nice. Let's go to the next question, which is insert 5 geometric means between 32 by 9 and 81 by 2. So 81 by 2 upon 32 by 9, this is going to be the common ratio raised to the sixth power, which means that this is going to be I think 3 to the fourth power upon 2 to the first power, into the reciprocal of this is going to be 9 upon 32, which is going to be 3 to the second power upon 2 to the fifth power, and this is going to be r raised to sixth, which means that 3 upon 2 raised to 6 is equals to r raised to sixth, which means that r is equals to 3 by 2. Fine. So the sequence is going to look something like this: 32 by 9, you multiply it by 3 by 2, so that will give me, here you get 16, here you get 3, so 16 by 3, then you will get 8, then you will get I think 24, no wait, you will get 4 into 3 is supposed to be 12, then you will get so you take 2 out of it, get 6, and then 6 into 3 is 18, and then you take another 2 out of it, so you get 9 into 3 is 27, and then it becomes 81 upon 2. Fine. So there are 1 2 3 4 5 geometric means. This is correct. Okay, let's go to the next question. So the next question is find the geometric means of the following pairs of numbers. Fine. So 2 and 8, you have to find the geometric mean. So 2 something and 8, this is supposed to be a gp, which is an increasing gp basically. Fine. So this is going to be, say, b, then you have b by 2 equals to 8 by b, which means that b squared is equals to 16, which means that b should be plus minus 4, but this is supposed to be an increasing GP, so it cannot be minus 4, so it has to be plus 4. This was easy. Let's go to the next one, which is a cubed b and ab square ab cubed. Okay, fine. So well, let's just assume that a and b are positive, because otherwise this can be pretty difficult. No, wait, maybe not. So here's the deal. This is going to be ab into a squared, then you have something, and then you have ab into b squared. Fine. So my guess is this is going to be ab into ab. Probably yes. uh, what's the deal? Okay, so a squared, this is obviously positive, b squared is obviously positive. Fine. We don't know if ab is positive or negative. If ab is positive, um, then we can say that this is a positive quantity, this is a positive quantity, and their geometric mean would be ab into ab. That should be okay. Yeah, the square root of this product, so ab whole square, the root of that is just ab, and then you have this thing, the root of that is obviously, I mean, a square b square is ab whole square, so root of that is also ab. That's nice. If ab is negative, then this is a negative quantity, this is also negative quantity, so you should have a negative quantity in between them. So you have ab into a squared, and then you won't have this. Okay, you won't have this, because over here you should actually be having a negative quantity, so you will be having negative of ab squared. Fine. So that's nice. There are two cases to this problem, but anyway, let's go to the next question, which is you have to find the geometric mean of -8 and -2. So that's okay. So -8 something, and then you have -2. So the square root of 8 into 2, that's going to be 16. The square root of that is 4, but here it should be a negative number, so I will say it's going to be -4. That's nice. This was easy. Let's go to the next question. If a is the GM of 2 and 1 by 4, find a. So you have 2a and 1 by 4. This is supposed to be a GP, which means that a squared is equals to 2 into 1 by 4, which is 1 by 2, which means that a is equals to, well, 1 by root 2, I think. So this is going to be 2, 1 by root 2, and 1 by 4, I think. So yeah, that is correct. Fine. Let's go to the next question, which is where is it? Okay, prove that the product of n geometric means between two quantities is equal to the nth power of a geometric mean between those two quantities. Okay, so the normal geometric mean, which is the single geometric mean. Okay, fine. So here's the deal. Suppose there are n geometric means, and their product is going to be something like this. Okay, so you have a, you have g1, which is the first geometric mean, then the second, then third, and it keeps on going like that till n, and then you have b. Now here's what I'm going to use. Every time you go one step from here to here, you have to jump. Actually you have to multiply by an r. That's what I call a jump. And when you go from here to here, you are going backwards, you have to do a reverse import. You have to multiply by 1 upon r, sorry, 1 upon r. So when you multiply these two, those into r and into 1 upon r, they get cancelled, and you just get a and b. This happens for all of them. For g2, gn minus 1, for g3, gn minus 2, and it keeps on going like that. So what I'm going to say is that gk and gn minus k minus 1, right? I think no, this is supposed to be 1, so okay, plus 1. Fine. This product is always going to be a times b for all integers k, I mean for all natural numbers k till n obviously. So there we go. Let's just use this. Okay, let's call this p. So I can also write p as okay, we don't want this, we don't want these over there, we don't want these. So this is a multiplication. So okay, I can also write p as gn minus 1 into gn minus 2. It keeps on going like till g1. Okay, so when I multiply these two equations, I get p squared is equal to g1 gn, but that's obviously just a into b. And then you have g2 into gn minus 1, well that's also a into b, and it keeps on going like that till you have n of them, right? You have n pairs, so it keeps on going till n pairs. So that gives me a into b raised to the nth power, which means that p is going to be the square root of this quantity, which can also be written as square root of ab raised to the nth power. This was easy. And guess what, this thing, this is the normal geometric mean of a and b. So this is obviously correct. Let's go to the next question. So just erase this, go to the next question. Okay, if am, no wait, okay, find the two numbers whose am is 25 and whose gm is 20. So am is 25, which means that this sum has to be 50, and their geometric mean is 20, which means that 20 square, which is 400, that is going to be equal to its product, right? The product of these two numbers. That's fine. So we'll just multiply this by a. So this will give me a squared plus ab is equals to 50a. You know that ab is 400, so you will get a squared plus 400 is equals to 50a. Fine. Which means that a squared minus 50a plus 400 is equals to 0. So let's see, 400 can be written as 20 into 20, or it can be written as 40 into 10. Fine. So it's going to be a minus 10 into a minus 40 is equals to 0. So either a equals to 10 or a equals to 40. If a equals to 10, then b is equals to 40. If a equals to 40, then b equals to 10 from this equation, the first one. Fine. Which means that those two numbers are going to be 10 and 40, no matter the order. Fine. Let's go to the next question. Just erase this first. So those two numbers are 10 and 40. Okay, so the next question is, if the am of two positive numbers a and b, oh, a is greater than b, is twice their, so these are two positive numbers and a is greater than b, is the am of these two numbers is twice their geometric mean. Prove that a is to b is equals to 2 is to root 2 plus root 3 is to 2 minus root 3. Okay, fine. So there we go. Basically, we have to prove that a upon b is equals to 2 plus root 3 upon 2 minus root 3. But we will get to that later. First of all, you have that their arithmetic mean, which is a plus b upon 2. This is twice their geometric mean, which is the square root of ab. Okay, that means that you have a plus b is equals to 4 square root of ab. Let's just square these, right? So a squared plus 2ab plus b squared is equals to 16ab. Fine. Which means that a squared minus, well, 14ab plus b squared is going to be equal to 0. So now I'm going to divide this by b squared. So that will give me a upon b whole squared minus 14 into a upon b plus 1. This is also equal to 0. Fine. So we have to find a upon b, right? Let's call this a upon b as x. So you have a quadratic equation, x squared minus 14x plus 1 equals to 0. Let's just solve this using the formula. So x equals to minus, which is 14, plus minus root b squared is 14 squared, right? 14 squared is going to be 4 into 7 squared is 49, minus 4 is here, this is just 4, upon 2a, which is just 2 over here. Fine, this is going to be 7 plus minus the square root of, okay, that 2 gets cancelled because you can get that 4 out. 49 minus 1 is 48. Fine, which is, well, okay, so it's going to be 49 plus minus, oh, here's the deal. A is strictly greater than b, which means that this a upon b, this thing cannot be less than 1. So if this was 7 minus root 48, then this quantity surely is less than 1, which is not correct. So you have you must have 7 plus root 48 as your answer. Otherwise it just does not work, because a should be greater than b. Fine, so let's see what we can get is equals to 7 plus I guess this is 16 into 3, so that can be written as 4 root 3. Fine, and now we have to bring this into this form. Let's just bring this into that form. So I'm going to rationalize basically the denominator of this quotient. So that's going to be 4 minus 3, which is 1, and then over here you have 2 plus root 3 squared, so that's going to be 4 plus 3 plus 22 is 4, so 4 root 3, which is going to be 7 plus 4 root 3. Yep, that's exactly what we got over here. So this can be written as, well, if you it can be written as, well, what was it, 2 plus root 3 whole squared, which by the way can also be written as 2 plus root 3 into 2 plus root 3 into 2 minus root 3 is just 1 upon 2 minus root 3. So that's done. So this question was nice. Let's go to the next question. Why does it take such a big amount of time to erase it? Fine. Okay, so the next question is, where is it? Okay, if am and, oh wait, I think, oh okay, if 1 am a and 2 geometric means g1 and g2 are inserted between any two possible numbers, any two positive numbers, oh sorry, any two positive numbers, show that g1 squared upon g2 plus g2 squared upon g1 is equal to 2 times of a. Fine, so suppose you have a, you have g1, you have g2, and you have b. This is going to be a geometric series. Fine, then we have to show this 2 times a, that's just going to be a plus b, no problem. And g1 squared upon g2, well, we can use the fact that you have to multiply by r to get this. So g1 upon g2, this is going to be 1 upon r, so you will have 1 upon r into g1 plus g2 upon g1, that's going to be r into, you have g2. Also you have to multiply by r to get this thing, which means that g1 upon r would be a, and you have to multiply by r to get this thing. So r into g2 is obviously b, which is, yes, it is 2 times of a. So this was easy. Let's go to the next question. So you have to construct a quadratic in x such that am of its roots is a and gm is g, which means that the sum of its root, okay, it's a quadratic, so there are two roots, so alpha plus beta, the am of its roots is a, so 2 times of a equals to the sum of its root. Fine, and the gm is g, which means that alpha into beta is going to be g squared. That's nice. So you will just have x squared minus 2a plus g squared equals to 0. This is the quadratic polynomial which has alpha beta is its root, and the arithmetic mean of alpha beta is a, and geometric mean is g. Fine, easy. Let's go to the next question, which is the sum of two numbers is 6 times their geometric mean. Okay, so a plus b is equals to 6 times the geometric mean, which is obviously root of ab. Show that the numbers are in the ratio 3 plus 2 upon root 2 plus okay is 2, 3 minus 2 upon root 2. So you have to show that a upon b is 3 plus 2 root 2 upon 3 minus 2 times root 2. Fine. Maybe we just need to rationalize this. So let's multiply by 3 plus 2 root 2. This will give us 1 over here, and then this thing will get squared, so you will have 9 plus 8. 3 into 2 is 6, and then this is supposed to be 2, so 12 root 2, which is 17 plus 12 root 2. That's what we should get for a upon b. Let's just use this equation and let's see what we can get. So you will have a squared plus 2ab plus b squared, just squaring this, equals to 36ab. Fine. So you will have, okay, by the way, I do not know if this is positive or negative, and right now we are just dealing with the case where both of them are positive. Okay, fine. So let's see what we get. Okay, so you got a squared plus 2ab plus b squared equals to 36ab, which means that a squared minus of 34ab plus b squared equals to 0. So let's just divide this by b squared, so you will get a upon b squared minus 34 into a upon b plus 1 is equals to 0. So a upon b, what is this thing, is equal to minus b, which is going to be 34 plus minus root b squared. 34 squared, that can be written as let's see, 4 into you got 2 into 17 squared. Fine. Minus 4ac, which is going to be 4 upon 2a, which is just 2 over here. This is going to be 17 plus minus, well, that 4 comes out, so you just got root of 17 squared minus 1. 17 squared is 29, so it's going to be 288, which is 17 plus 1. Let's see, this is multiple of 4, so you have 2 root of this is going to be 7, and this is going to be 2. Okay, fine, which is going to be 17 plus minus, let's see, this is multiple of 4 once again, so you got 4 root of 132 is going to be 18. That is it, I think. No, you can pull out a 3 from it, so you get 17 plus minus 12 root of multiplied by 9, you get 2. And yeah, so one of them can be this thing, so this can be 17 plus 12 root 2 or 17 minus 12 root 2. But here's the deal, if it was going to be 17 plus 12 root 2, that implies that a is greater than b if 17 plus 12 root 2. If this was 17 minus 12 root 2, then we can use the fact that 17 minus 12 root 2 is nothing but 1 upon 17 plus 12 root 2. So you will get a upon b as that thing, so b upon a will be 17 plus 12 root 2, and eventually you will get b is greater than a, and which means that the ratio is in fact always 17 plus 2 root 2 when you go from the smaller one to the bigger one. So that's correct. Just move on to the next question. Okay, so the next question is okay, so if am and gm of roots of a quadratic equation are 8 and 5 respectively, then obtain the quadratic equation. Okay, so in the last question itself, I think we did this. Yes, so the quadratic equation is going to be x squared minus 2 times of a x plus g squared is equals to 0. Okay, so over here the am is given as 8 and the gm is given as 5. So x squared minus 16x plus 25 is equals to 0. That was easy. I mean, really easy. Not a big deal at all. Okay, let's go to the next question, which is if am and gm of two positive numbers a and b are 10 and 18 10 and 8 respectively, find the numbers. That's easy. So a plus b is going to be 2 times the am, which is 20, and a into b is going to be the square of the gm, which is 64. So now let's multiply this by a, so you get a squared plus ab equals to 20a. ab is 64, so you get a squared minus 20a plus 64 is equals to 0. Let's see, 64 can be written as 8 into 8, or it can be written as 32 into 2, that's not fine. So 16 into 4, yes, a minus 16 into a minus 4 is equals to 0. So a equals to 4 or a equals to 16. If a equals to 4, then b has to be 16. If a is 16, then b is 4. Yeah, and that was the last question. So thank you so much for watching this video. See you in the next video.